what we need is a few functions in that we know about, that we can say, hey, that's this type of function, and be able to recognize the shape, more or less, of that function. So that's what we're going to hit a little bit here next few minutes, call them common functions. And we talked about one earlier, the f of x equals mx plus b. That's our linear function. And we know it's a line, and the slope is m, and the b is the y-intercept. Same old, right? Okay. Well, actually, the other ones here we're going to cover somewhat simpler in that they don't have a whole lot. They just involve the x value, some operation on the x value. For example, before I go into that, the other thing that we'll, of course, here, 2x plus 3, let's just do one. So we got y-intercept is 3, slope is 2 over 1, so that's rise over run. Rise 2, run 1. So there's a lot. But the other thing about these that we'll ask for as far as homework on these is, what's the domain and range? Well, pretty simple one on linear functions, because the x's could be any number, right? I could plug in any number there. And what about the y values? Any limits on the y values? It's negative infinity to positive infinity on both of those. It won't be the case on all these, but for the linear function, yeah, the domain and range is, both of them are all real numbers. Any number, x can be any number, and then the y value, the function values come out to be any number as well. Okay, so we'll also talk about the domain and range as we go along with these. All right, so yeah, let's go to the f of x equals x squared. Again, since we're just kind of starting these out, let's just go with a table of values to figure out the graph, what the graph looks like of this. They already know, but if I do, let's just do 5, usually is sufficient on these, 5 points. So the x values, -2 to +2. Well, we're squaring these, so -2 squared is +4, right? These are always going to be positives. -1 squared, +1. 0 squared, 0. 1 squared, 1. 2 squared is 4. Yeah, so you get this shape. 0, 0, 1, 1, 2, 4. -1, +1, -2, +4. And it's not hard. 3 would be 9, -3 would be 9. Yeah, so you get, and if we graph more points, we'd see that it's not pointed here, it's curved, right? It's curved around, and then these values they go up pretty quickly on the ends there. So yeah, we get this shape. They refer to it, and I think some of the homework may ask you about the name of this. This is just the squaring function. But basically what we want you to know there is that an x squared graph, yeah, it's going to have this shape. It's called a parabola, and we're going to talk a lot more about parabolas in a few days. But yeah, so that one's the parabola shape. And that's what you get with the x squared graph. Domain and range wise, what do we got? Well, since I have the function, when we're talking about the domain, the input values, x can be anything. I can input anything. Or if I look at the graph here, yeah, all the x's are covered by a point. X can be anything. And when you go to the range, a lot of times it's better to look at the graph there. I mean, you can think about it too, but from the equation. But if you look at the graph, the range, the y values, there's nothing below the x-axis. So there's no negative y values again. The y values basically start at 0, don't they? 0 to infinity. So the range for the squaring function is 0 to infinity. Don't get any negative y values for that one. All right. A few others. F of x equals x cubed. As far as the table goes, now on the x cubed, what's going to happen there as far as the y values? When I do a negative x value, what's going to happen to the y value? It's going to be negative as well, because negative 2 cubed, negative 2 times negative 2 times negative 2, that's going to be a negative 8. So you're going to get negative y values on the negative 8. For the negative 2, negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed, 2 cubed is 8. Yeah, so you do get negative y values here. And so you get a different shape. Of course, this is the cubing function. So 0 is still 0, 1 I'm at 1, but then 2 jumps to 8. 2 I'm at 8, negative 1 I'm at negative 1. And then a negative 2 and a negative 8. Negative 8. Okay. Negative 2 and a negative 8. Yeah, so we get a whole different shape on the cubing function. Yeah, it goes up on the right side, but it's down on the left side there. So it's a little different shape there, cubing function. As far as the domain range go, again, x can be anything, negative infinity, positive infinity. And then we just mentioned on the range, the y values, they have negative values too, so that's also negative infinity, positive. Okay? Couple more. I'm going to show you. All right, so f of x equals the absolute value function. All right, so the absolute value function, as far as negative 2 to positive 2 for x goes, well, you're doing the absolute value. So the y value is going to be the absolute value of negative 2 for the first one there. And absolute value of negative 2 is positive 2, yeah. Takes all the negatives and makes it positive, doesn't it? Negative 1, absolute value is positive 1. 0, 0, 1, 1, and 2, 2. So it's similar to the squaring, but a little different. Because here's what we get. So negative 2, I'm at positive 2. Negative 1, I'm at positive 1. 0, I'm at 0. 1, I'm at 1 again, and 2, I'm at 2. 3, I'm at 3. So it's not hard to imagine there. What's going to happen? Well, the deal is these come in differently than the squaring function because these make a V shape, don't they? The V-shaped graph is the absolute value of x shape. Yeah, you get a V shape as opposed to a curved shape like the squaring function there. It's the V shape. And then the domain and range on that. Again, the square root of x, that's not going to limit what x can be. X can be anything, still negative infinity, positive infinity. But again, looking at the graph or thinking about the equation there, what y values do I get? Do I get anything negative?
Nope.
No. Nothing negative. It's all positive, both besides 0. So again, the range is 0 to infinity. Is that okay? And then one more that we'll utilize here, some other stuff. F of x equals the square root of x. All right, so this is the first one of these common functions anyway. we have to be selective, I guess you might say, for x's, because if I do my -2 to -1 to 0, when I plug those in, the deal with that is the square root of -2, I can say that it's an I thing, but we're graphing. We're not graphing anything that's imaginary here. So we'll just say that's not a real number. Thus it's not going to be on the graph. Same thing with the square root of -1, right? Not a real number. You could say it's I, but as far as graphing goes, we can't graph that on the graphs we're doing. Okay. Yeah, this one's going to start at 0, isn't it? Square root of 0, I can do that. That's 0. 1, I can do the square root of 1. That's 1. Square root of 2, well, it's not a nice number. Whoops. Square root of 2 is over here. That's not a nice number, but it's a number. What's the square root of 2, approximately? So let me punch it in. Square root of 2?
1.414.
Okay.
And keep going.
Yeah, it's about 1.4. Okay, so we can use that. I think on these I want you at least 5 points, so we need a couple more. You can just keep going. We can do nice ones. 4 and 9 would be nice ones, but you can do 3 and 4 just as well. It'll be fine. Square root of 3, it's not a nice number, but it's a number. 1.7 approximately. And then square root of 4, back to nice numbers, that's 2. So here's what shape we run into on this one. Nothing on the x's negative side. Starts at 0, 0. Goes to 1, 1. And then 2, we're at 1.4, so it's not much higher than that. 1.4. 3 is a little bit higher, 1.7. 4 is at 2. Yeah, then like I said, just to see that it doesn't keep going up, if we jump to 9, the square root of 9 is 3. So that's where we wind up getting our 3. 5, 6, 7, 8, 9. 9 we would be up to 3. But it is going up, isn't it? It's not flattening out. Okay, so here's the shape. It keeps going up gradually going up, but it's going up. Keep that in mind. Okay. Sort of a half a graph, if you will. All right. What's our domain and range? Well, this is the first one where we have kind of a limited domain, because we don't have all x values possible here. What do we say? Can't have anything x negative. Starts at 0. 0 to infinity would be our domain, wouldn't it? What about the range? Same thing, isn't it? The y values also start at 0. We're talking about the y. There's nothing negative y value, so yeah, the y values also start at 0, but they keep going because this graph, it's not growing up as fast as the parabola was, but it's going up. And so you're going to get a y value of 10, a y value of 100. It'll be way on down there, but